Today we're going to look at a few of our properties of logarithms. So when we're looking at these things, we're basically saying what would happen if I had a log with base whatever of, and then I had some multiplication happening. I either have some division happening, or maybe I have something raised to an exponent. So when we're looking at these things, let's just keep in mind our simple example here of the fact that I know log base 10 of 100 equals 2, right? So if I have 10 raised to the second, it will give me 100. So when I'm looking at this thing, let's say I rewrote this, okay? So I'm going to rewrite this, and instead I'm going to write it as log base 10 of, now here I'm going to write it as 10 times, as soon as I can write a times sign, 10, okay? And we still know this is nothing different than what we had up here, right? 10 times 10 is 100, so this thing is still going to equal 2. But let's think about how we can separate this thing. We can talk about this as log base 10 of 10 plus log base 10 of 10. As we look at each of these, log base of the thing that's the same as the base is just 1. So I'm saying 1 plus 1 equals 2. This is my product property for logarithms. So we can do this for different values. So say, for example, instead of it just being 10 times 10, it was 6, right? So if I want to talk about log base 5 of 6, that's the same thing as saying log base 5 of 2 plus log base 5 of 3. So again, the 6 is going to be 2 times 3. So if I want to talk about that 6, I can talk about it as log base 5 of 2 plus log base 5 of 3. These are equivalent, and this is my product property. So now let's look at our quotient property. So I'm going to get rid of this stuff here. We're going to look at the quotient property next. So I'm going to maintain that one simple example there we have as our reference. And let's look at one of these things. So let's say, for example, I had log base 10. Now, again, typically we don't see the base 10 here. We just write log because it's common log, but I'm just writing it to have everything super explicit. And now I'm going to rewrite 100 as 1,000 divided by 10, okay? And this is still going to equal 2. There's nothing different between 1,000 divided by 10 and 100. So as I look at this thing, I'm going to break this up with my quotient property. My quotient property is going to say I can take log base 10 of 100, 1,000, and subtract log base 10 of 10. When I look at this, this is going to give me 3, right? 10 to the what gives me 1,000, 10 to the third. So this is 3 minus, we said this is 1, equals 2. Here we see that we have 3 minus 1 equals 2, and that is correct. So here's an example of our quotient property, and I can split this thing out too for other values. So let's say, for example, I had, I don't know, log base 5 of 7 halves. Okay, log base 5 of 7 halves is equal to log base 5 of 7 minus log base 5 of 2. So we see this can work for other values as well. It doesn't need to just be one of our kind of like simplified versions. We'll do one more here using exponents next. So now let's look at this thing in terms of exponents. So now instead of writing log 100, I'm going to write log base 10 of 10 squared. So when we see it written like this, I have the of thing which is being squared. And so what this is saying is I can take this and rewrite it as saying, okay, well, this is going to be log base 10 of 10, I'm just putting this in parentheses to make it clear, plus log base 10 of 10. This is the one we just covered before, so this would be my product property here, right? 10 squared is just 10 times 10. So if it's 10 times 10, I can split it into my product property. We've seen that before, but now I'm going to say there's a little bit kind of a better way of doing it, right? So why do we do multiplication in the first place? It's just kind of fancy addition. So it's just easier and it saves time. So now I'm going to say, since I have 10 squared here, I have 2 log base 10 of 10s here. And so we look at this, this is 1. 2 times 1 is 2. We have verified this. I'll show you with another value here. Let's say I was doing log base 5 of 7 to the third, okay? So this is just 7 to the third, what is it, like 243 or something like that? So when I look at this, I'm saying, okay, well, let's say I had, I don't think it's not, is it 243? That's gonna drive me crazy until I figure that out. It's 343, I knew that wasn't right. So 343, right? So instead of writing it as 343, I'm gonna represent it as 7 to the third. So as I look at this thing, this is the same thing as saying 3 times log base 5 of 7. So this thing here is the same thing as rewriting it with now my exponent coming out in front. That is my power property for logarithms. So when we're doing these things, that's the kind of big three that we're going to be introducing, and we're going to be able to use these properties to expand and to condense on our logarithms, and we'll see that later on. So here we're just going to use a couple examples here to illustrate this. So the first one here, I have log base 5 of 3/7. It's telling me that log base 5 of 3 is this number. It's telling me that log base 5 of 7 is this number, and we just want to approximate the following. So basically what this is saying is, hey, you don't know how to do the change of base formula yet, so just use these values as placeholders. Again, we will get to a point very shortly here where we can do our change of base and we can figure out what any of these things are, but for right now it's just telling us, okay, this is this value and this is this value here. So let's take a look at the first one here. So looking at this one here, I have log base 5 of, and then I've got some division stuff going on. If I have division stuff going on, this is my quotient property of logarithms. So I'm going to scroll back up just a little bit, and I'm going to highlight this one here. So quotient property says if I have division here, numerator divided by, and then I've got denominator here, it's going to be that numerator thing minus the denominator thing. So this is going to split. Oops, I think I can keep it like this and fit everything I want. There we go. So looking at this here, this is going to split, and so this will now become log base 5 of 3 minus log base 5 of 7. And then we just plug in those values. So log base 5 of 3 is my 0.683, and then my log base 5 of 7 is this 1.209. So I do the subtraction there, and I get my final answer as an approximation here. For the next one, as I look at this thing, I'm saying, okay, well here I have log base 5 of 21. These can sometimes be difficult. Now the reason these can sometimes be difficult is people just say, okay, well it is 21. Well, yeah, I mean, it kind of is, but another way of thinking about this is 21 is 3 times 7. So when I'm looking at this, I'm looking really at log, log base 5 of 3 times 7. So when I write it like that, I see I have my product property here. So here I have a product of these two things, so therefore it's going to be 3 plus 7. So here I have my log split out, and here I have log base 5 of 3 plus log base 5 of 7. And now here we add those two up, and we get our final answer. For the last one, you could make an argument that this is 7 times 7. I'm going to say there's a better way of doing it, and that's to think of it as 7 squared. So when we do this thing, right, if I put like 343, you know, there's only so many times I want to write 7 times 7 times 7 before I give up and just say, okay, it's 7 raised to the blah. So when we're looking at this one, I'm going to actually push us in the direction of saying we're going to represent it with an exponent. So we're going to say this is 7 squared. If I have an exponent inside, so this thing is going to turn into 7 squared like this. And now I'm going to say, okay, well, let's take this 2 and bring it out in front. That's my power property for logarithms. So 2 out in front, now I have log base 5 of 7. Log base 5 of 7 was that 1.209, and so now it's just 2 times that to get my final answer here. we can use these to expand on different expressions. So when I look at this, I'm trying to take this thing and pull it apart. So each one of these is basically going to get split as much as it can. Pay special attention that this is my numerator and that this is my denominator. Okay, so the first thing that I recommend you do is split that numerator denominator. So when I look at this thing, I'm actually going to do this in our color here, to our denominator in orange. So I'm going to split this, and so the first move I'm going to make is I'm going to say, okay, well, this is going to be log base 2 of, and now here's the numerator thing, and then it's going to be minus log base 2 of, and now here's my denominator thing. So the reason for this is that my denominator is the subtraction part, right? So this is going to be y in here, and here I get 7x to the third. So now I want to continue from here. The trickiest thing about these, and it doesn't really happen here, but when we do the subtraction part, it's for this entire log thing. So I'm going to put a big annoying bracket around here, and this is just to help us in the future. If this was, say, for example, 2y, we don't want to forget to distribute our negative sign, right? So as we expand out further from here, which doesn't happen in this particular problem, we don't want to lose that distribution of the negative. So just keep that in mind for future problems. So let's continue now with the numerator stuff. So this is my product property. So I have multiplication happening here. So this is going to turn into log base 2 of 7 plus log base 2 of x to the third. And then I've got my minus log base 2 of y. Now as I look at this, I can go a little bit further with my x value here, and this is my power property. So here I have x to the third. This 3 as an exponent can come on out in front. So now I'm going to have a final answer of log base 2 of 7 plus 3 log base 2 of x minus log base 2 of y. So this would be my expanded logarithmic expression here. It may not seem evident as of right now why we want to do this, but this is advantageous for us in solving problems later on. Looking at condensing logarithmic expressions. So now we're going the flip of the coin. So now I'm saying, okay, well, instead of expanding this thing, I want to take a bunch of them and smash them together. So wherever I have addition, that's going to be my product property. Wherever I have subtraction, that's going to be my quotient property. So just keep that in mind. The first thing I'll typically do when I get a problem like this is I'll deal with my power property stuff first. So do I have any numbers in front of these logs? And I do right here. So this being a 2, this is actually log of 2 squared. And since I don't see any bases on these are all just log base 10. So this is my common log. Don't see any bases. That's because it's log base 10. So the first thing I'm going to do is I'm going to focus on this power property here. And so this will become log 6 plus log, and you can write 2 squared or you can write 4. I'm going to just write it as 4 here. So this is just 2 squared. And then I'm going to say minus log 3. Okay. From here, I want to focus on the fact that I've got addition between all of these things and subtraction with all of these things. Now when I say all of these things, it made sense for the first one, but it didn't really make sense for the second one. Well, the reason it didn't really make sense is because there's only one of them, right? So I'm only talking about one thing. But in the future, you may have multiple negative logs, and what that's going to basically symbolize for you is that those are all of your denominator things. All of those denominator things are then going to be doing the whole product property. So for this one, again, a bit of a simple example, but the product property on top here is going to be evident. So when we look at this, instead of writing it as log 6 plus log 4, I'm going to change this into log of 24. And then I'm going to say, okay, well, I've got my log 24 minus log 3. Well, when I've got subtraction like this turns into division. This is my quotient property. So now this is going to become log of 24 over 3. This simplifies to just being log 8. So my final answer here would be log 8. Here we get to our change of base formula. Finally, right? I've been referencing this for a few days now. When we want to evaluate a specific log, so whatever the base is, I don't always just want to do it with base 10. I don't always just want to do it with the base e. Now, if I did want to do that, it would look like this. So I'm just going to say stuff we can do so far. So I'll say like our now stuff versus the stuff we'll be able to do 30 seconds from now. So right now I could do log 5, and this is log base 10 of 5. So another way of writing this is like that, right? I could figure this out by punching it in on a calculator. I could also do natural log 5 by punching it in on a calculator, and again, that's using base e. So these are the two things I'm able to do right now, and that's really all the log buttons on my calculator. So I need to find a way of getting things into these two forms. Now the way we do that is with our change of base formula. So my change of base formula says that I can do log base c of u, and that's equal to log base b of u over log base b of c. Now this b just got introduced. There's only two b values that I'm ever going to want to use. I'm going to want to use b as 10, and that's for my common log, or I want to use b as e, and that's for my natural log. So this again is a value we are introducing. You can use other values, right? If I wanted to do log base 2 of 5 and then log base 2 of 7, whatever, right? If I was doing 5/7, that's fine, except for then I'm going to have to do my change of base formula again because I don't know what that log base 2 of 5 and 2 of 7 is. So when we're doing these things, our b value is always either going to be 10 or e, and it doesn't matter which you use because it's going to essentially just cancel off. When I'm looking at this thing, I'm going to say, okay, this number on top comes from the of thing. My base number here is the bottom thing. So when I'm looking at these, the u is higher, goes up top. C is lower, goes down bottom. So we'll do a couple examples like this. So looking at, what color have we not used yet? Yellow. So let's say we're doing, I don't know, log base 17 of 5. Cool. As of right now, 30 seconds ago or whatever, a minute ago, we would not have been able to figure this out. But what we're going to turn this into is one of two things. One is that I could turn this into log of 5 over log of 17, and that is the same thing. So again, this is just a ratio, so it's going to be the same thing as natural log of 5 over natural log of 17. So it doesn't matter whether you're using base 10 or base e here, we're able to evaluate either way with the calculator. Let's see here. So what do we get? Do this one really quickly. So we got 5 and 17. So this gives us approximately, so we'll call it 0.568 1, approximately. So when we're looking at these, we're able to round, typically it'll be like 4 decimal places, but a lot of times what I'll just want is an exact answer. So a lot of times I'm just looking for this as my exact answer, but sometimes I'll ask you to evaluate to maybe like 4 decimal places to come up with an approximation. So we should be able to do this. Here's a couple examples here. Here using our change of base formula, here we have log base 3 of 7. So this 3 is going to go to the bottom, 7 is going to go to the top, and I can use either log base 10, which is my common log, or natural log, which is using log base e. These numbers obviously are going to be different than these numbers, right? Log 7 versus natural log of 7 are two very different numbers. Okay, cool. It's because they're using different bases. But my change of base formula is going to do the same on both. So either I'm using log base 10, or log base e, aka natural log, and I'm going to get the same answer. So regardless of whichever route you choose to go, typically I'll just do natural log. I don't know why, I just do it. You can use log, it doesn't really matter. So again, both of these will arrive at the same conclusion. And that is it for today.